to kind of understand malware evolution trends and things like that. My name is Dan Jones. My employer would prefer that I don't say where I work, so I'll just say I've been in InfoSec for about 7 years. And this is all my own work. It's nothing I've been doing for them. So a lot of what started this, I really started to get more into the malware defense side of things about 3 years ago. And there's tons of families, variants. Things change every day. So some of them are pretty similar. Some of them are very different. So you've got children that branch off of a parent. You've got the Infinity, Goon, Redkit relationships. You've got things that spawn off and then get killed by more successful exploit kits. And a lot of these businesses, it's really the business model that wins out, not necessarily the technical expertise. So you'll see, some technically advanced exploit kits that die because they're not as good at their marketing and their customer service. So kind of hard to really understand which ones are the most dangerous from a likelihood perspective. And then my real concern was, so which ones are most dangerous for the organization that I'm trying to protect, and my family and friends. I think any of us that are in InfoSec are always asked what do I do to stay safe? And so just kind of understanding what's going on in the world around us. So I started with just some text files where I'd keep a bunch of information as I found good sources of details. That quickly became ineffective to find intelligence that I read that was good about a source. So I went to starting using things like Evernote, or I stood up a MetaWiki for a little while, MediaWiki, to try and figure out some of this stuff. But even that really didn't work well for understanding relationships. I even played with the Confluence from Agile software, or Jira, and that worked okay. Fed a bunch of stuff into MongoDB. I've got some scrapers that pull RSS feeds, and now some Twitter information into MongoDB. And while it's an awesome database, it really didn't work well for understanding the relationships and trends. So I started looking at Neo4j. I was actually doing some exporting of data from Mongo into some mind mapping software when I came across Neo4j. And what's awesome is it's a graph database. So unlike a relational database, which is horrible at relationships, graph database actually works really well. Everything's interconnected by its actual relationship. And at the root of it, you have nodes and relationships. And it's really easy to visualize the similarities and the differences between things because it's a very graphical representation of a relationship. So the data storage is really flexible. You don't have to set up anything beforehand. Define keys on the fly if you want to, define relationship types and labels as you're importing data. And the results are immediately apparent. So as soon as you run a query, when I was doing a lot of my initial development of this, it was really easy to see the net effect of relationships that I was building and ways to refine or better add contextual data to relationships that exist. And it made complex malware easier to understand, and especially to describe how it relates to other people. When you can show some visuals, typically that's a really good way to help people see what you're seeing mentally. So the language that Neo4j uses as a query syntax is called Cypher. And really quick, so that you guys can get the most out of what I'm going to show you, I just want to go over Cypher really quick. It's pretty simple. You have the notation for a given node. So here you're going to see the in there on that second bullet. Let's see, there we go. This in here is the node identifier. So if you're thinking in programming or algebra or whatever, in would be your variable. And then the node is a label for a given node. So if we were going to take this back to some object-oriented development type stuff, the in is your actual object that's been instantiated, so I give a name for that. And then the node would be more of a class type. And then you can add, so like here you see I've got a name which is called something and other data which has data point in it. So we can add attributes to a given node. We can do the same thing for a relationship. So here you see in brackets in the relationship notation, you've got an R, which is the alias for that relationship, as well as a label for that type of relationship called related to. And then we've got two different aliases for the two nodes associated in the relationship that we're seeing here. And you can also add, I don't do it, but you can add attributes to a relationship as well. So you can say, the first time that this relationship was seen, or the last time it was seen, or other information like that. So we have a match, which is similar to a select in SQL. It's going to tell it what types of nodes we're looking for. And then we also have a where, which is similar to a where in SQL, which lets us refine the query to specific types of data points. And then a return is going to say what is returned. So here you see in this example, we're matching node n something where it's related to node 2, and then we're telling it to return n1 and n2. So this is going to return all nodes that are related to a node named something. We can also write that differently with a where clause. So there's a little bit of flexibility in how you run your matches. You need to use a node whenever you're trying to use a function of Cypher to, for instance, when you do a regex match or trying to do some rescaling or what am I trying to think of? Changing a data point. So if you want to cast an integer as a string or a string as an integer and vice versa, you'll need to use a where. But what's really cool about Cypher, what I love about it, is it's basically SQL meets ASCII art. Everything you can draw on a whiteboard, you can pretty easily turn into a Cypher query. So yeah, just a note about the demo. I've got some intel that I built these relationships off of through some trusted information sharing groups that I'm in. And so a lot of the data that I'm presenting, or the only data I'm presenting, is anything that had a URL in it. So a lot of my intel sources that I'm using weren't as clean to match. So I basically assume if it's available on the internet, then I can show it here. Yeah, so we'll get into a demo. All right, so here's basically your Neo4j browser instance. When you install Neo4j and you launch the server process, it's going to spawn a web GUI for you to basically run Cypher queries. You can also run them from the command line as well. So we'll grab our first Cypher query here, and basically I'm just going to show you around the different types of data that I've got, and then we'll start working on relationships. If you click over here, it's going to show you the different types of node labels and relationship labels that are available. So first we're going to look at some pre-canned things I added. So I basically added different services that a piece of malware may come across. So we can view things as well in a graph, or we can view them in rows. So you'll see some different service types. We also have some service types. So these are a layer of abstraction away from a given type of service. And then we have what I've called delivery vectors. So you may receive malware through a phishing email. You may receive it through malvertising, compromised website, TDS, things like that. So we can look at a relationship of those with this query here. So what I'm basically saying is show me a delivery vector, and we'll call that DV, where a service type is related to that. And I don't know necessarily what the relationship label is using this type of query, but we'll find that out here. So here we'll see that the web enables malvertising, TDSs, compromised websites. Obviously, email is going to allow phishing and spear phishing, things like that. So these are things that I've added to help add context to explain malware variations and things like that to other people. So here we'll also see service types. So here's where we're relating. Email can come through a variety of services. Web comes through a variety of services. And we can chain those two together pretty easily. In fact, I should just do that. But you can copy and paste a lot of these together to kind of build. So you can take two smaller queries that work and can concatenate those together into a bigger query. So here we're going to see from the service level down through, because I have HTTP available to my users, which gives me the web, they can come across compromised websites or malvertising. Because we have email available, we have phishing. So looking at relationships, we can also query based on a label for that relationship. So if I want to know who is developing what, I can simply just say, show me a relationship where someone developed something. And that's going to show here a bunch of pre-canned information that I've added about different, and this actually comes through a lot of the vuln research that I've incorporated in here. But here you'll see Microsoft develops all these things, Oracle send Java. I stayed away from doing version-specific stuff because it grows your chains out really far and makes it kind of hard to see. But anyway, we can see that relationship here. The one downside to doing a query where you're going off of the relationship label is if you go back into your rows, you'll see I don't have anything about my nodes. All I have is details about my relationships. And they're empty because I don't have any attributes associated with those relationships. So I tried to rewrite those using node query specific information. So we run the same query, which is functionally the exact same thing. But the beauty of this is now if I wanted to export information to take some action on it, I've got attributes about my nodes that are related and how they're related. So good information to have there if we were trying to share it to a computer or something like that to do some other analytics on. Some other pre-canned information is I started looking at the motive. That doesn't work. Let's go that. So I started looking at motives as well as different malware payloads and then how they're delivered. We'll get into a lot of that cool stuff here in a second. But we can also say another cool thing we can do about a relationship. In this query, I'm saying, show me a motive, and then I don't know necessarily the label, and I don't know what the node is, but show me everything that's anything that's not related to it, or one layer in a relationship further. So show me basically anything related to a motive. And what that'll show us here is that we have motives and we have payloads. And so you'll see, if we, and this is just scoped to the information I was able to pull. I have quite a bit more information than this, but it's hard to pull it out cleanly. But here we'll see, we're worried about system takeovers, what I basically call someone leaving behind a remote access Trojan or something like that. We have your classic bank account takeover stuff, so your DriedX Dire stuff, your Zbot, things like that. Click fraud motivated guys. Your everyone's favorite right now, the crypto wall and Tesla Crypt stuff. Anyway, but that's a good example of a query where I may not know how things are related, and I just want to do some exploration of, how do these things become related. So here I'll show you what info we're going over, and I've trended away from a lot of the blog stuff to a Twitter parser I'm playing with right now. Seems like I get information faster through Twitter. And so here's where we're going to see, basically here's where a lot of my information came from. A bunch of just different great blogs out there. And so we can also look at this guy here. And so here we're going to have all this information is coming from 328 nodes all over the place. So let's see. And we'll actually go through, this might be valuable. So we'll look at, here's the exploits that are covered by that. So we've got some old stuff. I've got one reference to black hole because it's there's a variant of black hole with some intel about that. So I kept that in there, even though poor Ponch is sad his exploit kit's gone. So here what we're looking at, we started getting into some cool stuff with Neo4j, is we're looking at how exploits are related to payloads and what intel, where I gathered it from. So it's interesting for me to see, maybe I'm getting more information about a specific malware family through certain intel feeds. So this is only showing the intel report, so we have to take that out one step further if we want to figure out who the author of that is. But just kind of good to know, especially if I want to go back and figure out, all right, I know I know Angler's now delivering Tesla Crypt. When did that happen? We can look in that. We can look in the rows here, and I can start to see. All right, now here's Angler's now doing Alpha Crypt, right? And that I started seeing that around these dates. You can also do some min-max type analysis as well, which we'll get into some date-specific things later on in the demo. But so here's where we get into some fun stuff, where we can start to see kind of a complex query, and this one will take one a little longer to run. But here I'm matching intel on both sides of the chain. So show me where the payload and the exploit were related to similar things. So here I've got information about the payload as well as the exploit kit that's being used for those given payloads. So more good for a researcher, less for explaining to other people outside. But we can start to see some trends here. A lot of where nuclear and Angler are pretty common, and neutrino are pretty common for delivering a lot of this stuff, as well as where we're getting some of this information from. We can expand this out even further, and we go back to our earlier query, actually. We can even go and say, so show me the Intel source. Sorry guys, I struggle when one person's watching me type, and when 60 people are watching me, it's even worse. So kind of interesting, because now I can start to see some real cluster stuff of, Brad at malwareanalysis.net does some awesome stuff with covering Angler and things like that. But you can kind of start to see a lot of interesting relationships of who can see what, where you're going to get certain information, where you can do some more mining. It's actually really, really interesting with Twitter, and so I feel bad I wasn't able to clean that up and get that presented. But the Twitter stuff's pretty cool. There's some really good libraries out there actually that are pulling Twitter stuff into Neo4j. But that's just a good example of how you can relate some intel sources into what you're seeing and what's affecting your organization. So now let's get into some fun stuff. So exploit kits. Here we can, again, we're just going to say, show me where exploits are being used against certain, or which vulnerabilities are being used by certain exploit kits. So what's interesting here is if we start to look at this graph, can you kind of see where, if someone came to me tomorrow and said I can only patch for 10 vulns, which 10 vulns am I worried about? If we look here, you'll see right in the middle of these, or so maybe we say 20, right in the middle of all these EKs, you see where all of them are sharing very similar exploits. And so for me, that tells me, from a pure likelihood perspective, the odds of me hitting an EK that's going to be exploited, or that's going to exploit me, I want to make sure that I've got these things patched, just by looking at that relationship. Now, granted, the one big caveat to this is the only things that have been reported that I've seen through an Intel feed. So it doesn't mean they're not using other things, but it's a good way to go to somebody. We'll actually start relating this to software, and this would be a good way to go to your organization. So let's do that right here. That work at all? Okay. So here what's kind of interesting, if I was trying to drive a campaign for some aggressive patching in my organization or things like that, what we can see here is at the root of a lot of this, we have some flash problems and we have some IE problems in the middle of a lot of these exploit kits. And while it may be, 3 years ago I would have walked in with an Excel spreadsheet and said, here's all the exploits and this is a problem, but somehow this resonates better with people when they can see a bunch of arrows. What's really awesome is you could load, results from your vulnerability scanners and show actual assets as well in this type of diagram. So not only hey, these are active exploits in the wild, but here's the assets that have them. And then when you have server administrators or people that are responsible for desktops and workstations that have those vulns, they don't like all these arrows targeting their systems. So a great way to kind of tell the story in a way that people may quickly understand it. So here's where we can get into some more some complex queries here. So here what I'm basically looking for is show me where someone's motivated to perform financial extortion. And right now we're seeing that a lot through the fake AV, the crypto type malware. But so what I'm saying here is show me anywhere that someone's motivated by financial extortion, delivering a payload, and then show me the chain for the different type of software that's affected by those vulnerabilities through the EKs. So again, if we were going and this would be a really good example too with phishing or something like that. If they came and said, why do we have to patch our endpoints because we're worried about phishing or whatever the motive you're concerned with, you can really easily paint a picture of, hey, we got to worry about these things. Kind of paint that picture for aggressive patching, or you can even include your coverage for what SIGs you have in your IDSs that are covering this, different signatures that you're seeing through your endpoint protection software and things like that. So here what we can do too, getting back to tracking evolution and changes, we can scope this. We'll take this query and make it even nastier. So here I'm looking at what software is being targeted. Before it was everything that's ever been targeted by those different exploit kits, but now let's scope it to this year. So what have we seen this year? And unfortunately, again, I apologize, but my Twitter information has a little bit more detail here because more of my information came from that. But based just on what's been published from the intel sources I follow, you can see we've seen a significant change as we look. So here we're basically seeing, it's kind of fun as you can drag Flash out here, start to dissect some stuff, and you'll start to see a bigger propensity for certain exploits to target certain things, and the different EKs that are delivering different types of different variants of the crypto malware. But if we change this and go back to 2014, we can see a completely different graph. We see that it's targeting more of the OS specific vulnerabilities. Still, we've got Flash out here, but IE is in the middle of a lot of this, and we really didn't see any. Crypto stuff started becoming more popular last year, so we don't have a ton of stuff exploiting it there. But kind of an interesting way of you can do some temporal comparison and see differences earlier on. So we can also scope this another way. We can say, again, we kind of know Flash is known insecurity's friend, but if we look here, here we've actually scoped it to Flash specifically. So kind of cool to be able to draw out, hey, we've got, that is really hard to see, isn't it? Anyway, we can start to see, the different variants, and again, this is scoped specifically to Flash. So if we pull that out, we'll be able to visualize a different, get rid of Flash player here. If only getting rid of Flash was that easy, right? Sorry, Adobe, I know you're here. Anyway, we can see it's really hard to tackle, but we can start to dissect some problem areas for us earlier on, and start to look for, again, we see that cluster here. So as we grab Flash and start to look at what happens when we play with Flash a little bit, we'll start to see some common things that all, where everything's revolving around something, we can definitely see a cluster, and that cluster is something that we can start to tackle and address and reduce our overall attack surface. So what I've been playing with lately, and I wasn't prepared to share much of the details yet, but what gets really cool is I've been pulling in malware I've been analyzing and adding attributes into my personal system about different sample data. So here, all I'm giving is the MD. Actually, some of these are, yeah, these are SHA-256. So the SHA-256 hash of some malware samples, and I'm starting to play with different attributes. So how different payloads are using different types of techniques to avoid detection, and you can start to see some family groupings occur there too. But you can even take your samples and start to look at. We've got somebody floating around out here. Good old Upatri. You can see some cool information there as well as you start to pull sample information in. I mean, and really, I'm not trying to show the data that I've looked at, but just a general concept here of how looking at security problems from a different angle can be valuable to paint a bigger picture for ourselves and for people we're trying to help protect. And this one's really fun. I saved it for last in case I drop my database, but match in, return in is going to show us everything. But what's really cool about this actually is it kind of shows you the root of a lot of our problems over the last little bit. Which gets into one of my big pain points, which I haven't been able to tackle in Neo4j yet. I've spent a lot of time on it. But temporal analysis, so even though I was tracking evolution, the thing I learned is that tracking change inside evolution or in the graph database is really tough. There's no way to partition any of this information yet. I know they've got it on their request for changes and things like that. But what gets really cool though is you can see a ton of intel, a ton of other things that at the end. Oh, now I'm going to break it. Come on. At the end of the day, though, you're going to start to see, nuclear, angular, neutrino being a huge problem. We've got Fiesta a little bit here. And then we've got some vulns. So the tan-colored stuff is the intel information, and the, you kind of see it here on the side here. The brown-colored stuff is the vulnerabilities. But we start to see some significant groupings as we look at everything from just kind of a real macro view and looking at our problems as a whole. So anyway, kind of some information. I went really short, I apologize. But is there anybody that has any questions about this as a concept or anything here that happy to run any queries you want to see too or anything like that? But so this is part of why I started playing with it on my own and not, this is all stuff I've done on my own when I've had time. I'm not sure yet if there's an enterprise grade application for this. I've actually played with, on a separate thread, taking information from like the log to timeline stuff that we use for digital forensics and dumping that into Neo4j, and that gets pretty interesting too. Yeah, I don't have anything awesome yet. Part of why I haven't started to use it at work. But for me, it was just, how do I figure this stuff out? I honestly think, though, if you load your vulnerability data into here of what systems are vulnerable with what things, you could really start throwing some internal application administrator information on there. People are going to stop wanting to be in the middle of a big bubble of problems. So it might be a great way in an automated fashion. The beautiful thing about Neo4j is it's got a REST API for everything. Everything you can do in the command line, you can do through a REST API. So you can have a threat map available that's easily explainable to anybody. Worst case scenario, you can drag around a bunch of bubbles and entertain managers for a couple hours. But really, it's a great way of representing a lot of complex problems. You'll notice there's not a ton of data in here because it's not a great, from what I've played with, it's not a great way to store a ton of data. I've still got most of my notes for a lot of these, like if we go into a given Intel report, I'm basically using the title of the Intel report as my primary key, and I've got that information in Mongo just because Mongo can store a lot of that stuff a lot better. But yeah, anyway. Any other questions or? The input data. Oh, thanks for asking that. So yeah, I've published all this stuff up to GitHub. So the question was, what's the input data look like? So I've published everything. I've been using some REST calls and other stuff to populate this. I've been using some. There's a great Ruby library out there that lets you use this. But I've actually put everything that I exported for today there is a .cyp file which can be read by the command line shell tool. And here's basically all your Cypher stuff. And so right here I'm reading it from a CSV file. You'll have to go through and just do a global substitution on path to wherever you stick this stuff. But it's going to go through and it's going to pull out anything in any of these CSV files. So if we go in here and look at the input, it's really simple. So like for instance, payloads is just a straight list of payloads that are there. And then as we get into the relationships, here we're building an exploit to a payload relationship, basically just key to key. So I've got a really horrible, guys that work with me can attest that web design is not my forte. I'd be great in 1997, but anyway, I've got some code that allows me to dump a lot of this stuff into a web GUI and easily populate this. But at the end of the day, it's easily represented by CSV files as well. So if you want to take this data and play around with it for whatever it's worth, go ahead and pull this, and you can get up and running right away. My horrible CSS theme. This is actually pretty good for me. I'm pretty proud of this. But my horrible CSS theme is also available in this grass file, which is the Neo4j way of colorizing your inputs, but that's available too because there's only a few colors that it uses out of the box. Yeah, so the presentation's up here as well because the notes don't come across in the PDF they sent out. And then all the queries that I ran today are also in here too, so if you want to play around with it and see stuff there. But it's actually really easy to load. So, any other questions at all? They want to run a microphone out to you here. One sec.
Okay, so as you're working with this, do you end up having to hand maintain the more detailed information and then keep this up to date, or do you just export from the other one, or how do you?
So that's a great question, actually. I played early on. My whole goal was like automate all this stuff, and I learned personally that I didn't learn anything. I had a bunch of cool data in there. I mean, I learned some things, but I didn't learn a lot about it. So I kind of went back and I started actually maintaining a lot of this on my own, so that I could be interacting with the data. And again, it's not. I mean, we're not going to solve InfoSec problems tomorrow with Neo4j, but it's a great way to kind of wrap your head around things and watch the different, evolutionary trends of things and how things, what does this one article I just read, how does that fit into the bigger picture of everything that's happening and what's going on here? So there is I've intended, or the way I've been operating with it has intentionally been manual to kind of keep close to the data. But the stuff I'm pulling from Mongo and things like that, I've got some frameworks that I use to kind of mine a lot of the stuff I'm trying to consume. That stuff will alert me to new things, and that's what I've triaged what I'm reading based on that. So, yeah. But it could be as automated or as manual as you want to be with it. Awesome. Any other questions? Sweet. Let's go to lunch. Thanks, guys.